आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सॉल्यूशन पाओ। डाउनलोड नाउ।
Hello everyone, the question is define the following terms, and the terms given are mole fraction and ideal solution, which we have to define. Second part of the question is 15 gram of an unknown molecular material is dissolved in 450 gram of water. The resulting solution freezes at minus 0.34 degrees Celsius. So what is the molar mass of the material? So in the question it is said that 15 gram of an unknown molecular material is dissolved in 450 gram of water and the resulting solution freezes at minus 0.34 degrees Celsius. So we have to find out the molar mass of the material, and it is given that molar depression in the freezing point constant for water is 1.86 Kelvin kg per mole. So now let's start, and first we will define the mole fraction. So here comes mole fraction. So mole fraction of a component is the ratio of the number of moles of that component to the total number of moles of all the components in the solution. Clear? So let's understand it through an example. So consider a binary solution containing solute A and solvent B. And binary solution is basically mixture of liquids that are miscible with each other. So mixture of liquids that are miscible with each other in a solution is considered as binary solution. Now moving forward, so basically let Na be the number of moles of solute A and Xa be the mole fraction of solute A. Similarly, for solvent B, consider Nb as the number of moles for solvent B and Xb as mole fraction of solvent B. Clear? Now mole fraction of solute A will be number of moles of solute A up to the number of moles of solute A plus number of moles of solvent B. So this is the number of moles of that component and number of moles of the all components present in the solution. Similarly, mole fraction of solvent B will be number of moles of solvent B divided by number of moles of solute A plus number of moles of solvent B. Clear? So in this way we can find out the mole fraction. Here a point to be noted is in binary solution the sum of the mole fractions of solute and solvent is equal to unity. Clear? Now moving forward to the next term, that is ideal solution. So ideal solution It is basically a homogeneous solution where the interaction between the molecules of components that are solute and solvents is exactly same to the interaction between the molecules of each component itself. So basically, ideal solution is a homogeneous solution in which the interaction between the molecules of components that are solute and solvent is exactly similar to the interactions between the molecules of each component itself. Now, it also obeys Raoult's law. So, for a binary ideal solution, the total vapor pressure of the solution is equal to the predicted by Raoult's law. Ideal solution follows Raoult's law for all range of temperatures and pressures. And for binary ideal solution, total vapor pressure of the solution is equal to the pressure predicted by the Raoult's law, like this. So this is the total pressure and this is the total vapor pressure of solute A and vapor pressure of solvent B, and predicted by the Raoult's law, it will be write as P naught A into mole fraction of A plus P naught B into mole fraction of solvent B. Now moving to the second part of the question. 15 gram of an unknown molecular material is dissolved in 450 gram of water. The resulting solution freezes at minus 0.34 degrees Celsius. So we have to find out the molar mass of that material. Let's find out. Now, using the formula for the depression in the freezing point to calculate the molar mass of the solute, the formula is delta TF is equals to 1000 into KF into W2 divided by W1 into M2. Clear? So in this formula, delta TF represents the depression in the freezing point. Right? KF represents the molar depression in the freezing point constant. Right? W2 is the mass of the solute. M2 is the molar mass of the solute, which we have to find out. Molar mass of the solute, and W1 is the mass of the solvent. Clear? Now after rearranging this formula, we will get M2 is equals to 1000 into KF into W2 divided by W1 into delta TF. Now let's put out the all values. So 1000 into 1.86 into 15 divided by 450 into 0.34. So after solving it, we will get the value 182.35 gram per mole. Therefore, molar mass of the material is 182.35 gram per mole. So this is the solution. Thank you.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।